Okay, Assalamualaikum and very good morning. Today I would like to explain about the example 2.9, which is the power needs of a car to accelerate. So, from this question says, determine the power required to accelerate 900 kilogram of car shown, which is this is their mass. Alright, so in the figure to interpret from rest to a velocity of 18 kilometer per hour. So this is the V2 and this one, this is the V1, which is the rest, which means the velocity are 0. V equals to 0. In 20 seconds, which is this is their times in 20 seconds on level of roads. So the solution is the power is required to accelerate a car to a specified velocity is to be determined. So as we know that when we find to the power, we have to know the formula of the works. So this formula which is WA. WA equals to 1 over 2 mv square. This also known as the kinetic energy. The same formula with the kinetic energy. So from this, we know that WA. So the first one is 1 over 2. The mass of the car is 900 kilogram. And then the velocity. So the velocity in here, it says 18 kilometer per hour and V and then other one is 0. So V equals to 18 kilometer per hour and then the V1 is 0 kilometer per hour, which is from rest. So from the velocities one, we should change the kilometer per hour, so this one to meter per second, which is ms negative 1. So what we should do, yes, also the v square here is the different velocity, which means v final or v2 is minus by v1 or the v initial. So apart from here, it says 100 over 2, 1 over 2 times 900, and then it says 18,000 meter and 3,600 seconds. And why? It is because we want to change from kilometer per hour to meter per second. So we need to change the unit. So for kilometer to meter, we know that 18 kilometer times the 1 kilometer equals to 1,000 meters. So that's mean 10 power of 3. Alright. So this one is meter. Okay. The second one, which is the hour. As we know that 1 hour, as we know that 1 hour we have 16 minutes and we have the 16 seconds. So the total is 3,600 seconds. So this will be 3,600 seconds. So years giving squares. So here begin, okay. And so we minus this one is VF, you know that V2 or V final, and then minus the V1 which is 0 because it start from rest. Okay. And then we have to change the unit because we want in kilojoule and we don't want in kilogram meter square over second square. So right here we have to change the unit, and we know that 1 kilogram, 1 kilojoule per kilogram years, and divided by 1000 meter square over s negative square. This is because we want to change the unit, we come to kilojoule, and we don't want in kilogram m2 s negative 2, and we don't want to do this, so we need a kilojoule. So apart from the calculations, we got the answer is 222 kilojoule. So that means the power needs to accelerate a car from 0 to 18 kilometer per hour is 222 kilojoule. Alright. So the average power, which is the power, is when we have to divide it, the work done by times. Okay. So right now we have WA is equals to WA divided by times. As we know that the power is 200, the put down is 222 divided by the times from 0 to 80 km per hour, which is 20 seconds. So the answer we get is 11.1 kilowatt. Alright. So, or we get the answer is 14.8, which is, and how we get that, because 1 times 10 power of 3 divided by 246. As we know, 1 kilowatts equals to 746 horsepower. Alright, so here, and the answer, the answer we got is 14.8 horsepower. So that's all from the example 2.9, the questions about power needs of a car to accelerate. So that's here the solutions from me. Alright.